Good morning, everyone. It is already into week two, and we're going to move to the end of the chapter right now, and I'm not sure why it's organized this way, but as we get into this week, we are actually going to look to finish most of this chapter with what we need to take care of. At the end of this chapter, it starts talking about equations. So, what I want to do is move right into this part while common denominators are fresh on our mind. As we get started, what I want to do is talk about the equations first, and then if you have any questions on any of the material that you kind of saw over the weekend, I didn't receive any emails with any screenshots. But if we have any questions, we'll go ahead and answer those as we go. My hope is by working on the rational equations, we can maybe deal with some of those questions as we go. So right now, what we're looking at is how do we solve something that has denominators that we don't want to have to worry about. Again, fractions make things very difficult, so if we can get rid of our fractions, then we don't have to worry about how this looks. So one of the things that I want us to kind of remember even from Algebra 1 is what do we do when we have these common denominators that we need to look for? And 4, 2, and 5, if we dealt with a common denominator, we can get rid of that altogether and then just deal with an equation the way we're used to. So what I did was I already worked out for us one of the problems. So as you're looking at it, I want to go through what would have been an Algebra 1 situation. And something like this, instead of dealing with the fraction and trying to worry about 3/4 x plus 1/2 equals 4/5 x, if I'm able to get rid of those denominators, it makes life a lot easier. So what we're looking to do is I figured out that our common denominator, our LCM, was 20. And if I distributed the 20 to each of these fractions, I'm able to cancel the 4 in the denominator with the 20 here, leaving just 5. Shh. I'm able to cancel the 20 with the 2 here, leaving 10, and the 20 with the 5, leaving 4. And then what I'm going to do is just going to multiply what's left. So the denominators are all gone. What's on top is now 15x, a 10, and a 16x. And so really now, all of this, with all these fractions, and this, the 15x plus 10 equals 16x, those are equivalents. They're the exact same thing, just a lot easier to work with. And then we solve our equation the way we're supposed to. Now the catch is after you go through all that, you need to make sure that you actually then go back and check. Check to make sure that this is what it's supposed to be, because now that we've gone through and we've done all this work, we have to make sure that it actually still works in the problem. So 3 times 10 over 4 plus 1/2, does it actually equal 4 times 10 divided by 5? And with a little work, 30 divided by 4 we know is 7.5. If I add that to 1/2, does that equal 8? So in this case, 8 equals 8, so I know that that's an answer. Unfortunately, with a lot of the stuff that we're doing in math, we know that we have this issue where we have extraneous solutions. We know that we have issues where there might be a no solution. So we need to make sure that we check. This check is going to be very important. But for the most part, those are the steps that we're going to follow this entire time. The only difference is our denominator isn't going to be something as easy as just finding the number value. So let's look at something that's not so much Algebra 1, but a little bit more along the lines of what we're going to look at with Algebra 2. And again, it's still going to be a little bit easier than what we're going to see, but at least it's a good first step. I'm going to give you a second to copy that down. And what you can see is I do have our LCM. Didn't really have to do a whole bunch of work to figure this out. We do have 2 and 10. Obviously, 10 is going to be the common denominator, but we also need to make sure that x plus 3 gets involved. So our common denominator, our LCM, is 10 times x plus 3. So in order for me to do this, I'm going to now multiply everything through by 10 times x plus 3. Now, for the example, I am going to show the distribution throughout the problem. I'm not going to just do it mentally. Again, it's for note purposes that I want to make sure that we're going to show the distribution. So I'm going to, in my problem now, she's not happy with me right now. In this problem, I have all the original work and I've distributed through those 10 times x plus 3's. And I'm only doing this so that you can see in this example that what's on top will cancel with the bottom, and then I'm going to end up multiplying what's left. The 10 on top and the 2 on the bottom cancel into 5 and 1, and the 10 on top and the 10 on the bottom cancel. So what's left now is 10 times 2, 15, because 5 times 3, 15 times x plus 3, and then this 19 times x plus 3. And I make sure that I show, at least for my own purpose, and I don't make any mistakes, because I will say this morning, in trying to do some of these practice problems to be ready, I forgot one value and the whole thing was messed up, and 20 minutes later I realized that there was a mistake. So the bigger the problems get, the more steps you should show. Even if you are pretty confident like I was, I still would suggest showing all of it. And if something doesn't feel right, just go back and check that you copied it wrong. Or if you copied it wrong, check that you have all of the values the right way. Most of the time that's where the error comes. Not with not knowing how to solve. It truly is you just didn't copy it right, or you missed a negative sign. So now we end up with 20 plus 15x plus 45 equals 19x plus 57. And simplifying and solving, we end up with x equals 2. Now again, we should check, because we need to make sure that if I plug 2 in, that 2 over 5 plus 3 over 2 would equal 19 over 10. So 2 over 2 plus 3 over 2, is that equal to 19 over 10? And what we do find out is 2/5 plus 3/2. If we did do the common denominator, you end up with multiplying by 2, multiplying by 5, and you end up with 19 over 10 equals 19 over 10. So this is a solution. Now the only other thing that you would need to make sure is if you are asked, so again, if asked, we know x cannot equal -3 because our denominator up here was x plus 3. So again, if asked, we need to make sure that you do have the domain is appropriately answered. So with just the first two problems, the entire idea is find your LCM, distribute through the entire equation to keep it equal, and then solve. Once you solve, check to make sure that you have all your solutions. So I'll give that a second. Anybody have any questions so far? I will say make sure that you guys stay on track. Make sure that you are answering all of your no-read questions. Make sure that you are completing all of your work. I now have a list of who administration has contacted between the entire building, not just obviously my class, but they are checking. I finished grading. I just have to put in all of the late work and all the test corrections, so please do not worry. I still have to go through that. I will say it takes a little longer when I'm looking at everything on a computer screen because I did have quite a few handed in on a computer via PDFs, so please keep that in mind. Shh, lay down. So with the most part, know that at least with this chapter, you will have at least one more, if not, it will be 2 more no reassignments that will be spread out, obviously. But I need to make sure that even though the deadline in the computer says April 12th, please understand that those are just so I don't have to reset anything for somebody who may have came in late. They should be done each week. That way you can kind of budget your time a little bit better. I'm trying not to overburden you. Math is a little different, and I know that there's a lot of steps to master before you can actually feel comfortable with it. So just stay on track. Any questions? Okay, so let's take a look at some of the stuff that we have prepared. And I have a few examples here that I'd like for us to try, and I'll give you a second to copy that down. And what I'm going to do is kind of set up steps off to the side here. So the first step is to find the LCM. The second step is to distribute. And it's through the entire equation to keep it equal. The third step is to solve. And our fourth step is to check. And remember that the check is, do you have solutions? Are there extraneous solutions? So we want to make sure that we're accounting for all of this. So what I want to do with this is when you're going to find the LCM, a lot of times it's smart to factor your denominator so that you can see, do you have one of everything in every denominator? And by factoring this, I can see that I'm going to need an n plus 1 and an n minus 1. And 3, 4, and 2 tells me that my LCM is going to end up being a 12. So the LCM here is 12, and then n minus 1, n plus 1. So I need to make sure that when I'm multiplying everything through, I use all of that. My numbers give me a 12. I have to have my n plus 1 and my n minus 1. So when I multiply, it's going to kind of look like this, at least on my paper every time. And that way I'm keeping track of what I'm distributing. Now, I'm not going to tell you that every time we do this, you have to show the distribution unless it makes it easier on you. Doesn't matter to me. So I am going to distribute to the first one. And what's going to happen is I know that 3 and 12 should cancel to a 4. That the n plus 1s are going to cancel, but I'm left with this. So just because I know that I'm going to have a few that want to see it, I am, for each one of these, going to show the distribution one more time. You do not have to show the distribution if you're confident that you know what's going on. So as I distributed this to everything, to keep it equal, it has to go to both sides of the equal sign or it won't be equal. I do have this 7n over 3 times n plus 1 minus, here's our 5 times 4 times n minus 1, and equals, here's our 3 times 2 n plus 1. So all I did was distribute that to all of it. Now I can reduce top to bottom. So once I have this, the 12 and the 3, there's the 4 that I was talking about. The n plus 1s are going to cancel. The 4 and the 12 cancel, and there's the 3 we talked about. And then the n minus 1s are going to cancel. And this 2 and this 12 leaves us with 6, and the n plus 1s are going to cancel. So again, if you can do that mentally, no need to write all that out. If you can't, write it out so you keep your head straight. So now we end up with 4 times 7n, which is a 28n times n minus 1. We have a 3 times 5, so there's that minus 15 times n plus 1. And then we have a 6 and a 3, which gives me 18 n minus 1. So over here, when we distribute again, 28n squared minus 28 minus 15n, and don't forget to distribute, minus 15, and then we have 18n minus 18. And now we have a quadratic. Now, at this point, everything from this chapter is done. At this point, this is all quadratic work. So we found our LCM, we distributed it through the equation. Now we're going to solve, regardless of how. We use all of those past skills to do so. So this should now be, and forgive me, look what I forgot to copy. So this should be 18n. So make sure that we have that. I forgot to put the n here when I recopied it down that fast, and I had to squeeze him in there, so now there's my n squared and my 18n. Glad I caught that fast enough. It's quadratic, so we're going to bring everything back, and we end up with 10n squared minus 25n minus 15 equals 0. Now to make this a little bit easier, I am going to factor out a 5, and I'm left with 2n squared minus 5n minus 3 equals 0. I am going to factor by grouping. And I know that 2 times 3 is negative 6 using our AC method. And if I have a negative 6 and I want it to go to negative 5, that's going to be a minus 6 plus 1. Makes it a little bit easier. And so I'm left with 5 times 2n plus 1 and n minus 3. So when we solve, we have our 2n plus 1 equals 0, our n minus 3 equals 0, and we find out n is negative 1/2 or n is 3. So found the LCM, distribute it through the equation, solved, and now we have to check. I will say using your calculator is going to be huge. So in my check, n equals negative 1/2. If I plug all that in, 7 times negative 1/2 over 3 times negative 1/2 plus 3 minus 5 over 4 times negative 1/2 minus 4 equals 3 times negative 1/2. And then this is 2 times negative 1/2 plus 2. I'm squeezing that guy in. This ends up being negative 3.5 over 1/2 minus 5 over, I can do that in my head, so we end up with negative 2, take away 4 more is a negative 6. And I want to see, is it equal to negative 1.5 over, well, 2 times negative 1/2 is negative 1. Negative 1 plus 2 is 1. I end up with negative 7 plus 5/6. Is that equal to negative 1.5? And the answer is no, because negative 7 plus 5 over 6 is a negative 6 and 1/6. It doesn't equal negative 1.5. So we just found out that this is an extraneous solution. Doesn't count. When you check n equals 3, you end up with 21 over 12 minus 5 over 8. Notice I didn't show you all the painstaking steps in between. And does that equal 9/8? 1 1/8 does equal 1 1/8. And again, all I did was check that in the calculator. So here is the only solution. Now I will tell you, when I went back and looked at the answer in the book, they told me -1/2 was a solution. I have checked this 5 times. It was really early. So if for some reason you find a mistake in here, let me know. Take a picture of it, send it to me. I'm curious. All right. Next one. We're going to go ahead and walk ourselves through 2 over x plus 1 minus x minus 1 over x minus 1, and then equals -2 over x squared minus 1. Following our steps, we are supposed to find the LCM first, distribute that through the entire equation to get rid of the fraction, solve, and check. So when we do this, and I'm just going to, so I don't redo the whole question like we did in the top one, don't forget this guy is x plus 1, almost did that, and x minus 1. That's the difference of 2 squares. So I kind of faintly put that in there. So the LCM for this one is simply x plus 1, x minus 1. So already this one seems a little nicer than the last one. Not as much to do. So we have our 2 over x plus 1 minus 1 over x minus 1 equals -2 over, and I'm going to distribute through this whole thing, that LCM, the x plus 1, the x minus 1, and it's going to go to each of them. And like I said, I'm not going to show the distribution this time. I am simply going to state that if this one is multiplied by our LCM, the x plus 1s are going to cancel, and it leaves us with 2 times x minus 1. This minus 1 over x minus 1, the x minus 1s are going to cancel, so I'm left with x plus 1. And then in this last one, they all cancel, and I'm left with -2. So we should end up with 2x minus 2 minus x minus 1, don't forget that negative, equals -2. So you end up with x minus 3 equals -2. So this was a really nice linear equation. X equals 1. Well, what's the problem with x equals 1? Anybody watching want to chime in and let me know what the problem with x equals 1 would be? Because here's where that check is important. Wasn't sure if anyone was awake yet today, but if anybody thinks they know the answer, go ahead and chime in. Thank you, Ren. You're absolutely right. The problem here isn't that it might not work out. We just can't have that x minus 1 in the denominator. That makes this, the domain, impossible. So what we find out, this is not possible. And so we end up with a situation where our answer is actually no solution. And it's possible, like in our first one, that we end up with an extraneous solution. It's also possible that we end up with something that's not possible because of a domain error. So in certain situations, make sure you do check, because anything you find wouldn't work. So we end up with our second example as a no solution. All right, last one, and then we're done for the day. And if you have any questions, I'll answer them. I'll give you a second because I'll try to do this one. I don't want to say a little faster, but at least with a lot less work. And again, you will find that as I load the notes from the live stream, I will also load the notes from last year. And that way you have a couple different sets of examples to work on. I am going to load some practice questions. You will find that I'm going to attach the answers, just not the work. That way, if you have any questions as to how the answers were there, at least this gives us something to work with tomorrow. And tomorrow's live stream will end up being just over any questions that you have. And then if you don't have any questions, we'll be done for the day. So make sure if you talk with anybody, and I'll post it on Google Classroom, let them know to check in. And then I think we're going to try to Zoom on Wednesday, same time, so it's not going to be any different. Hopefully others have paid attention to what times we're doing stuff as they go through. I know not everybody was online right away. We were trying to, so hopefully that works. All right, so as we go through this, I'm going to recopy. And when I recopy, I am going to factor the denominator so that I can get a better look at my common denominator. And I know that p plus 4 and p minus 2 is what that quadratic factors into. And that's, I would hope, a little bit more obvious, just because we already have a minus 2 and a plus 4. You can use the rest of your equation to kind of help figure out what the LCM is. And that way, when I do multiply everything by our LCM, wasn't as hard to factor that. So we're going to distribute that through, and the p minus 2's are going to cancel here, and that leaves me with 1 times p plus 4. The p plus 4's are going to cancel here, so that leaves me with the, oh, and look, all of it cancels. And then we're going to go ahead and the p plus 4's cancel here, and we end up with that. Sorry, a little distracted. So p plus 4 over here, 2p plus 1. This is going to be plus 2p minus 4 when we distribute. And we end up with a nice linear equation again. Bring all the p's to one side, all the numbers to the other, and we end up with p is 7/3. Now again, you have to check, and what I did again was I utilized my calculator so that I could use the ABC button and kind of cut to the chase. And when I plugged it in, it doesn't really matter how you choose to do so. I just plugged it into this part where I knew I factored it. And I have the 7/3 plus 4 in the denominator. I have the 7/3 minus 2 in the denominator. And then we end up with that guy. All in the calculator, I find out this is 3. And this guy comes out to be 2/3 over 2 1/9 plus 6 over 19. This ends up being 3 equals 3. And again, all I did was do it all in the calculator. So this is my solution. Now this is going to take a little bit more time working them out. You do need to, again, make sure if you are asked that you remember that the denominator is not allowed to be 2 or -4 because we see that up here. But if you're not asked, you don't have to say so. So those are the examples I have for the day. I will be loading things to Google Classroom so that you can take a look at these notes. You can take a look at the notes from the past year. You can do the practice questions. I will be assigning a no reassignment for this. I am going to state that the last question in the no reassignment, right now you can watch the video to know how to do it, but we are going to have a separate lesson on mixtures. It is part of this chapter, but there's so many parts to this section of the chapter that we kind of leave that separate. So if you do get the no reassignment, the very last question, you can watch the video to answer the question, or you can kind of hang off on answering that last one until we go through that. So do you guys have any questions before we sign off for the day? All right. If not, please make sure that you email me all your questions, that you check Google Classroom for all your updates, and you guys stay focused. I'll hang out for another 30 seconds and then we'll be done for the day.